If you've ever spent any time around custom car fabrication, you know the sound. And I'm not talking about the roar of a V8. I'm talking about that frustrated sigh from a builder holding a piece of very expensive and now very useless bent steel. For decades, building the perfect exhaust has been, well, part art, part science, and a whole lot of guesswork. Today, we're diving into a piece of software that promises to replace all of that guesswork with pure physics. So, here's the game plan. First, we're going to unpack the big problem, fabrication guesswork. Then, we'll introduce the science that literally fits in your pocket. We'll explore the missing middle in the software world that this thing was built for, see how it makes super complex engineering simple, and then finally, we'll look at its absolutely brilliant strategy for scaling up from regular enthusiasts all the way to enterprise clients. All right, so for years, the custom exhaust world has pretty much run on what the community lovingly calls bro science. You know what I mean? It's this mix of tribal knowledge, stories you hear from a buddy, and maybe some old dusty charts. And look, there's a certain romance to that, I get it. But that approach, it consistently costs fabricators real time, real money, and worst of all, real horsepower. I mean, think about it like this. A full custom piping job for a performance car can easily top $2,000. Now, would you be cool with your fabricator just kind of guessing at the best pipe diameter based on a gut feeling? Because that's what happens. That guesswork leads to piles of wasted material and hours of super expensive dyno time, all spent trying to tune around a problem that, frankly, shouldn't have been there in the first place. And this slide just lays it all out, doesn't it? On the left, you've got the old way. It's this frustrating cycle of guess, cut, weld, hope, and then usually end up with a disappointing dyno session. But on the right, that's the new way. It's data-driven. You engineer the performance from the very beginning, so the first time you build it, it's the right time. So how do we make that jump, from the old way to the new? Well, this is where the hero of our story enters the chat, a mobile app called Exhaust Modeler. It's designed to put professional-grade physics right into the palm of your hand. At its core, this app is an incredibly powerful simulator. It takes all the nitty-gritty variables of your specific engine and your dream exhaust design, and it runs them through this super sophisticated physics engine. We're talking thermodynamics, acoustic waves, gas velocity, the whole shebang, all to give you a super precise preview of how your system is going to perform in the real world. And this right here is what you get out of it. It's not some crazy, incomprehensible wall of data. No way. It's a clean, simple dashboard with the numbers that actually matter. Estimated horsepower impact, gas velocity, even a thermal score. It literally translates mind-bending fluid dynamics into a simple, digestible format. Okay, you might be wondering, if this is so useful, why hasn't a tool like this existed for the average shop or, the weekend warrior before? Well, the answer is this massive gap in the software market, a missing middle that left fabricators with some pretty terrible options. Just look at this breakdown. It tells the whole story. At the very top, you've got stuff like ANSYS Fluent. It's insanely powerful, but it costs tens of thousands of dollars a year, and you basically need a PhD to even know what you're doing. Then, way down at the other end, you've got tools like BendTech, and they're great, but they only tell you how to physically bend a pipe. They have zero clue about the physics happening inside it. Exhaust Modeler was built specifically to own that huge, underserved space right in the middle. So we know it feels a market gap, right? But it's real genius. The thing that makes it special is how it presents its findings. See, it's one thing to have the data. It's a completely different thing to make it actually usable for someone who's a master welder, not a fluid dynamics engineer. I absolutely love this quote from the app's own description because it just perfectly captures the whole vibe. It's not just a calculator. It's designed to feel like a pocket-sized engineering consultant that's right there with you, guiding you through the whole process. Okay, let's really zoom in on this UI. Over on the left, you've got the section flow analysis. This is just fantastic. It breaks down your entire system piece by piece, from the header runners all the way to the exhaust tip. You see where it says ideal primary tube size is calculated at 1.656 inches? It immediately shows the user how their 1.650-inch choice stacks up. That's instant, quantifiable feedback. Now, shift your eyes over to the right. This is the engineering analysis section, and honestly, this is the app's secret weapon. It takes all those numbers from the table and translates them into plain English. It's not just telling you the gas velocity is 289.8 feet per second, it's telling you that this is in the optimal range to maximize the scavenging pulse. It explains the why behind the numbers, which is so crucial. And then, this is where it gets really powerful. It doesn't just point out problems and leave you hanging. The potential improvements module gives you a clear, actionable punch list. It might say something like, your exhaust tip expansion is creating a high reversion risk. Add a reversion cone. It gives the fabricator a direct solution to a problem they might not have even known they had. And the depth here is just wild. I mean, it goes way beyond just horsepower. It's calculating back pressure, which is critical if you're working with turbos. It's calculating a reversion risk index. That's the chance of exhaust gas getting sucked back into the cylinder and killing your torque. It even projects the decibel level, so you can literally engineer the sound of the car before you ever hear it. Look, a great product is one thing, but a great go-to-market strategy, that's what separates successful companies from forgotten apps. And the plan for Exhaust Modeler is a true masterclass in how to scale a business by building a community first. As you can see, it's this really clever three-phase approach. It all starts with a low-cost app for enthusiasts, that's the B2C grassroots part, to get a ton of people using it and crowdsourcing data. Then, with proven results in hand, they pivot to a B2B model for professional shops. And the final step? Launch a full enterprise suite to take on the industry giants. And phase 1 kicks off right here with a price that's almost hard to believe. For just over $5, early adopters get lifetime access. This isn't about making a quick buck. Not at all. It's about completely eliminating the barrier to entry to build a massive user base as fast as humanly possible. And that massive user base? They have a mission. The goal is to get 10,000 active users. Because as all these builders design exhausts with the app and then test their actual cars on real-world dynos, they will generate thousands of case studies. They're essentially paying a tiny fee to become part of a huge, decentralized R&D department, creating the exact proof the company needs for its next phase. It's just genius. So, with that mountain of crowdsourced data, the company can finally pivot to phase 2. They can walk into any professional speed shop and make an economic argument that's impossible to ignore. Our software will save you thousands of dollars in wasted steel and billable dyno hours. And suddenly, a $360 annual subscription seems like an absolute no-brainer. It's an obvious investment with a clear, immediate return. Ultimately, Exhaust Modeler is this fascinating case study in democratizing incredibly complex technology. It's taking the raw power of a $50,000 enterprise software suite and putting it directly into the hands of the people who actually need it most. And it really makes you wonder, if software can solve this, one of the oldest, most analog problems in the garage, what other long-held piece of bro science is next on the chopping block?